Okay. Hi everybody. Hope you're doing well. So, sorry that I'm a little bit late, but happy to have you here. Today we will talk about the Open Pinball project. Basically, a very nice hardware solution, which yeah, I will show you today. Hey, Cobra, how you doing? So yeah, I see we got the experts here, so I will show it anyway, and you can correct anything that I'm saying wrong. So yeah, let's get started. I prepared a little presentation, and yeah, let's see how that works. That's wrong. That's the right one. Okay, so what is the Open Pinball project? The Open Pinball project is this nice hardware solution which has been built initially by you. I think that's how you pronounce it. And it's an open hardware, and yeah, basically you can build it your own for very little money, basically. So let's see. So first step, basically two versions, two variants. One is based on the, I think it's PSOC CPU. That's basically an old, now it's an old CPU by Cypress, and that's end of life by now. I think the CPU is roughly $4, including a USB to serial converter. I will show you that one later because I got it laying around. And there's a newer one which is STM32 based. So that's basically a new CPU, but the rest is the same. So the hardware. So basically this is the CPU here. I will show you in a minute. And then there are basically so-called planks, which implement the peripherals. That's, for example, I got those here. Those are for solenoids, so you could add any coils here or lights. And there are even some for incandescent bulbs. There are quite a few. I will show that next. So there are a lot of different types of planks, and it works that way that you got the CPU here, and it can interface 4 planks basically. So they are aligned as outlined on the right. So if you look at the CPU, that would be 0, 1, 2, 3. So I can put, for example, I could put those two. Those are 2. I just didn't break the PCBs apart. So I could put those here, for example, and I can put another 2 here. For example, I could put like 4 planks of solenoids on the CPU, for example. Yeah, I can have incandescents. That's like 8 incandescents on one plank, 4 solenoids plus 4 switches. So you can have, for example, 4 pop bumpers or 2 pop bumpers, 2 flipper fingers on there. And you can have stuff like switches. Switches is like, it's just basically you solder a connector line here. So that's super simple. Very effective cost-wise, but there's a little bit less electronic protection than on other hardware solutions. There's also a plank for switch matrix. I don't have it, but I've seen it. And there's lamp matrix. I think it's in development by Cobra. There's NeoPixels. That's basically also just a connector, and it's a specific pin. So it cannot live everywhere. I think it only can live on the 0 position, on the first position, because it uses some specific hardware features. And then there are carrier boards. Carrier boards basically just go around the whole CPU. So you got one board which then has all the stuff on it. It's, for example, Cobra has one of those, such a carrier board. It carries 2 CPUs. and then has basically an opinionated, it's called, I think. Yeah, basically a selection for you. So you cannot choose how many switches you have. You got a certain number of inputs routed as switches, another number then of incandescents, and so on. But those are basically very good fits for a typical machine. So this is very flexible, so you can exactly decide how you want your setup to look like. But if you want like a ready-made solution, then you could go for a board like the one from Cobra. But there are also other carrier boards. So yeah, what's all about this? So this is basically open software and open hardware. So the firmware is open, you can build it yourself, you can extend it, and this is also open hardware. So you can basically not only you have to build it your own. I'm not aware of anybody selling this as populated, but you can populate it either yourself. It's not hard, it's easy to solder. There's a good tutorial on Pinball Makers by Jeremy Wilson. He did an awesome job documenting how this is built, and that's really easy. And yeah, but you could also modify the hardware and build new planks and extend the firmware. There are a lot of options there. So basically, that's the strength and also, I guess, the weakness, because there's so many options. You also got a lot of choices, and in some way also a lot more rough edges, I think. But in general, it works well. So yeah, then there's one thing which is will come up in a minute. It's basically OPP Chains. So the first version, basically this one, you see it has an USB connector here, so you can plug it into USB. And it then has a serial connection, which then can go on to a next CPU, so you can chain those. So you can connect one to USB and then chain multiple CPUs and then have like planks on each of them. But I mean, you get the USB anyway, so you can also connect multiple CPUs directly to your PC via USB. And that's what yeah, I'll show you my setup in a minute. I also do this. But you can chain the first version. For the second version, this chaining option is no longer available, so there you have to connect each board individually via USB. Yes, and that's basically the general overview of this hardware. And now I will show you my hardware here. So this is yeah, that's better, right? So this is basically my hardware setup here. So what I got here is like this chain setup. So USB is coming in here, and then this CPU chains to the next one here in the back, right? And then this chains to the next CPU over here. So those three are basically in one chain. And then basically in the front here, I got another chain, which is coming in here via USB. I soldered the connectors because those are not that great if you connect them to an USB port. It's really a cheap connector. So just cut the USB cable and solder it, and you will have a good life. And then this one chains to the CPU in the back here. You cannot see as well. So now you can see it, right? And so I'll show you the hardware again. So this is basically, that's the bare CPU here. That's just the USB serial, that's the CPU. And yeah, then I'll show you. If I want to put inputs here, I would just solder, like, basically I would solder the connector here. And then I got 8 inputs, for example. And then I could put then I could, for example, put a connector line here, and then solder this on top. So that's basically, this is basically how this is done. So this is just soldered here with some header lines or header connector and headers. So basically that's how it's built. So it's super simple to build and also quite cheap. So this whole system which I got here is roughly, including everything, it's $100. And this is already a lot of inputs. So this is like what you need for basically 2 pinball machines. Usually you would need 4 or 5. I know like 2 to 3 boards. I think that's enough for a normal machine, depending on how much switches and coils you put on there. But I got like 8, 16, 24, 32, 40, 48 coils here, for example. And I don't know, probably 160 inputs or something. So that's basically how this works. And this is basically a special plank which goes here for the serial connection. So that's just to connect the serial stuff, which is not needed anymore on the newer versions. Yeah, and that's already how the Open Pinball project is built and how it works. If we look at MPF, that's what we can do next. I prepared something. So if you want to use it, the first thing in MPF you have to do is you have to set like the platform you're using to open pinball project OPP, and then you also have to set the driver boards to generation 2, because that's what you're to put there. Hi Redstream, you didn't miss like the STM32 overview because I didn't show the STM32 because I do not have one at the moment. I just showed like the general options, like which planks exist and so on. But I mean, the only thing which is different is like the CPU, right? So it's a different CPU board. You're not seeing that there. So it's a different CPU board, not this one. I think it's blue. It's not red. But other than that, from the perspective of MPF, I would say it's basically very similar. So it's still a CPU which can carry 4 planks and is connected via USB serial. So this connector basically is a USB serial. So this registers as a serial port in your PC, and MPF speaks the serial Open Pinball Project protocol, OPP, with the CPU. You have to make a few cuts and jumpers for the STM32 version. Yeah, I mean, I guess the best thing is to look at pinball makers, or maybe also the MPF docs, which Cobra wrote about this. So I think for the last plank, you have to put one wire here to connect it to another port over here, I think. But that's something. Yeah, there's like the pinball maker wiki, which is super well documented on like how this is done. So you have to add like those 2 wires here, and then it's basically the same. Building it is a little bit different, but it works very similar. It's more powerful, more options, and so on, but still the same planks work. So the planks didn't change. It's just a new CPU. And this is the old CPU. And here basically you describe how this is all built and like where are the connectors, how to solder it and so on. That's all described here. That's very well done. So there's also a power filter board from the Open Pinball project, which I do not have, but it's similar to the commercial power filter boards which are on the market. And here's also described how much the stuff costs and where you can get it and how to build it. And this is basically a larger plank with multiple solenoids. So there's a lot of stuff available. That's super cool. That's why I like this project. Yeah. And yeah, that's all described here. Yeah, right. And if you build the stuff in the beginning, you have to tell the CPU what it is. So you program that. I know, for example, this is solenoids, this is incandescents, this is inputs, and this is neopixels, for example. And afterwards, MPF will ask the hardware, "What are you?" And the hardware will tell, "Yeah, I got those inputs," and that's how this technically works. Yeah, and that's basically how the Open Pinball project is built. And now we can look at the configuration. So on Linux, it depends on the operating system again. Any chance of enabling MPF to configure the board? We can totally implement that if you want. So I guess we could add like a section here where you could, like, for example, have planks or something. Now I will complain, but if I didn't do this properly. So we could do, for example, planks, and then we could put like plank 0, 1, 0, 0 switches and so on, right? That would be possible. So I mean, the OPP programming tool is also in Python, so I don't see any reason why we couldn't just emit the same commands from MPF. That would be totally possible. I think we could even not persist it. So just write it at runtime and not save the configuration to the board, so that MPF would do it every time on startup. That might. I'm pretty certain that this would work, because I think it's a separate command to save it in OPP in the firmware. So that would be something. Yeah, I mean, we can work on that. That would be possible. So yeah, now I showed you how those chains work, and I got two OPP boards connected via USB, and those on Linux they are def tty acm0 and 1. So on Linux it's important that you stop like the modem manager, because otherwise Linux will think that this is a modem device and will try to configure dial-up stuff, and that will interfere with MPF. So stop that, but that's also in the docs. And then there's like, on the version I got, there is like a kernel module. It's SciTherm for a thermometer, which you have to unload, otherwise it will think and that it's measuring the temperature, and it will not appear as a serial device. But it's also documented. And after you did that, you get those nice devices, like I do. And now I tell them that chain 0 is this one, and chain 1 in MPF is this port. And afterwards, there's like the syntax for switches is like the chain 0, 0, then the plank 0, and then this chain 0, CPU 0, and then the input on the CPU. So like this is my first chain. That's the right one, and then the first CPU, and then the 24th input basically, or the 24th connector. And those is like those are the other, like that's at 8, 9, 10. And the same applies to coils. It's like 4, 5, 6, 7. That's the second plank on the first CPU and the first chain. And what I did is I connected a few events to pulse those coils for 100 milliseconds, and I also connected like an LED there. So we can run it now if you want. Let's see if I got it right. So now it's working again, or it's again, but MPF started and it connected to the Open Pinball project. And you cannot yet see my hardware, but make this happen. Okay. And all the stuff I'm showing is on the top right, on the bottom right board on this one. And what I did is I connected like the outputs to this breadboard here, and then connected them back to an input. So never do this if you got voltage on it. So I didn't connect any high voltage here. It's just the USB voltage. And basically I loop back the coil output to the input. So the first coil will activate the first switch. The second coil will activate the second switch, and so on. And you can see that if I activate it, for example. It's now a little bit slow, but you can see that something is happening. Here, let me make it larger. You can see that if I press 1, it emits this event test1, which then pulses the driver for 100 milliseconds as we configured it. And that then activates the switch because the driver is connected to the switch. So let's see, let's try it again. And then you can see that that's the display logic here, that's from MC. And then at the end, you can see that the switch becomes active and inactive again. And I connected all of them, so I can also do it with switch 2, 3, and 4. And I think for 3, yeah. For 3, you can also see that for 3, you can also see that those LEDs, those two are flashing here. So those are also connected to the same input. And what we can do now, for example, is to see how long does this actually take. And the way we can do that is we can look into the MPF log file. Let's see, let's do that. And I didn't prepare that part actually. So let's see what happens. Let's go to the last MPF log and maybe let's delete the logs once and restart it. And now we can see now we can run it once. And now we got exact like timestamps here in the log, right? So you can see that it sent the pulse command at 32,071 and it got the switch active like 10 milliseconds later, which is pretty good, I would say. Like that's like 10 milliseconds for sending the command via USB to the hardware and reading back the switch input. And I saw. So you can see that we also show the messages here. And yeah, and then we can see that like the switch is active for really almost 100 milliseconds. Like it's 1 millisecond less here, which might be like rounding, but the timing looks pretty good. Like then now we know that it's roughly 10 milliseconds. Let's try another switch. And here like pulsing at 219 and active at 227. So it's like even a little bit better, 8 milliseconds. And try another one, and it will be 46 and 61. So this one is a little bit like 15 milliseconds. And let's try again, 61, 69. So this one is at 8 milliseconds again. So we can now roughly say that our like input latency, basically the round trip latency, right? So the pulsing the coil to getting the event in MPF is roughly 10 milliseconds, which is good compared to other hardware platforms. It's really good. There are platforms with like more like 30 milliseconds. So from a software perspective, I mean, we can try a few times more, and yeah, 15 again, but still a little bit of jitter is normal. So that's basically how that is. What else could we try? So what we could also try, like having a flipper rule, like a hardware rule, which we can then trigger either via connecting like a switch physically, right? Or we could do the same. So we pulse an output, use that, connect this to an input, like I did here, right? So this coil which I'm pulsing is then triggering this input, and now we could trigger like a hardware rule with this input, and then we could see how fast the hardware rule is, because we already know how long it takes to activate this input. We could then remove the latency from this, right? So we can actually try that. So we got like an activation switch here, and let's start it again. If time, I love to hear how the firmware is created. So like, you mean how you flash the firmware or how you actually build the firmware? I mean, flashing the firmware is okay, right? Build. That's a good question, because I mean I checked this out, but I don't know actually. Yeah, I mean that's the question. Like, this is the repository, I'm pretty sure. Maybe not. It's SVN, it's not Git. And there's certainly somewhere visual pinball keycard. So basically, yeah, you get the keycard, that's the PCB layout. You get probably here. Yeah. To be honest, I never actually built it. So here is all the hardware stuff. Creator, what's that? Gen 2. No, that's basically the compiled stuff. So what you get is basically compiled firmware, but I'm pretty certain that you can build it. Yeah, that's true. You can flash it with this tool here, but I've honestly no idea where the code here is. But should be possible to find it. Let's search for C files, or it's probably C or C++. I have no idea. Ah, here. Here we got like all the. Yeah, it looks like the firmware is here. And yeah, you did this. He, right guy, he did a lot of work on this. So there's probably here there's the command documentation, and I don't know, maybe just make. No, there's probably some documentation somewhere on how to build this, but that's the source code here. And yeah, I mean, it's standard C code. I'm not sure if I can just compile it with GCC. Probably not. Yeah, it doesn't work, but you probably just need the correct IDE for that. But I would check the homepage from you, and he will certainly appreciate help on the firmware. So yeah, right. So it depends on the CPU how you flash the stuff. So for the Python stuff, I think you use this Gen 2 flash stuff, and then it changes for the STM. That's how this works with those. Basically, those are evaluation boards from Cypress, and they usually give you some utilities to work with them, and they depend on the hardware. So they are very cheap, and so you have to use the tools. It's not like, I mean, you could also use an Arduino, but that's a lot more expensive. But the tools are nicer in a lot of ways. Okay, he says how it works, how you ST-Link. Okay, catching the debugger and so on. Yeah, I mean, certainly you can build this, and you can change it and work with it and add anything you want. That's super nice. Yeah, I mean, we can try if this actually works. I didn't. Oh. No, I lost all the windows. And I stopped MPF, right? Let's start it again. And now we could try to enable the rules. Now it crashed because I didn't add like allow enable to my coil, but we can do that. And whoop. Now the rule is enabled, and we need the coil 2 to pulse it. I'm not sure if this works actually, but activation switch. Not quite. Maybe I messed up somehow. So I mean, coil 2 activates. It should activate the flipper for like a bit, but for some reasons it doesn't work. We have to see. yeah, that's basically how the Open Pinball project stuff works. It's that simple. I mean, with like, I want to do like another stream with the Cobra pin stuff when I get the stuff. So like it's like a carrier board which carries 2 of those STM CPUs, and it can do like NeoPixels and a lot more stuff. And yeah, that's why I want to show more. That is just basically the basics of the Open Pinball project for do-it-yourself stuff. But yeah, so yeah, I mean, do you want to see anything else? Yeah, thanks. That's nice. Basically, the expansion board is right. It's this the matrix plank, right? It's or the lamp matrix plank, right? Or what is the expansion board? So he's working on a lot of hardware stuff, so that's super cool. And I honestly kind of lost track. I hope that we still support all the stuff in MPF. Yeah, I do not have the Cobra pin board yet, unfortunately, but light matrix, 8 more solenoids, 8 more switches. Nice. That's really nice. So I guess it's like an 8x8 matrix, so 64 for yeah, lights, right? So incandescence probably, and then some more solenoids and switches. Nice. And it probably carries one CPU, right? So that makes sense because you need 8, I mean 16 outputs for the 8x8 matrix, 8 for solenoids, 8 for switches. So that's all the 32 pins of the CPU. That makes sense. Yeah, very cool. Yeah, so honestly, I had expected that the latency would be worse of OPP. So I expected more like 50 milliseconds on this hardware, but it's actually a lot better than I expected. And I believe that MPF only like holds the hardware at like 100 hertz, so that gives you the jitter component, right? So we could probably try to increase that. So you can think there's like pol hertz. Let's see what the default is. It's like, tell me, I don't know. Default, yeah, right. It's polling at 100 hertz, so that gives you a default latency of about 10 milliseconds. But we can try again with like a little bit more and see if this becomes even better then. So that's one of the things you can tune. I mean, if you set the poll frequency, how often it polls the switches, if you increase that, that will give you a little bit more base load on the serial. So you have to be a little bit careful about that. So, but we can still try here. Let's see how well this works. 42. Let's see. Now we pulsed and 107 and we got 121. It's not even better. Do it again. It's like, yeah, now we got 8 milliseconds. And now we got 22. Okay, might not even matter. 10 milliseconds. So 10 again. But that's very good for like all the USB stuff. So I mean that goes through the kernel, and it's not that I tuned my serial or something. There's a lot of stuff going on in the background. So you're working with MPF to VPX bridge right now. That's awesome. That's really awesome. And I think it's a great way to get started because you can just focus on building the game without fighting the hardware. I mean, at the beginning, you're usually fighting your hardware. You're wiring stuff wrong and stuff won't work, and you will look for electrical issues and so on. And it's nice to test it on a simulator in the beginning and then later switch to real hardware. I think that's one of the strengths of MPF, so that you can use virtual hardware and different physical hardware. And I mean, you can try OPP. If you don't like it, you can go with another hardware solution. So you're always fighting the software. I mean, everybody has his strong suit. My strong suit is more the software side, so I'm fighting the hardware. Maybe you're the other way around. Stress testing. So how do you want to stress test the hardware? So how would you want to do that? And we can do anything if you want. So like what you can do with OPP, I mean, I guess I told earlier, I basically programmed my hardware to tell it what it can do. And you can like run MPF hardware scan, and it will basically tell me what this hardware or how this hardware is configured, right? So you can see that I got 2 chains, which firmware versions I got. It's, I guess, relatively old. Then I got 2 incandescent planks with those numbers. I got some inputs on different cards and boards, and then I got like the solenoids here on different addresses. Those are basically the bus addresses. And I do not have any LEDs at the moment here. So rapid transactions on multiball. So yes, the problem is like reading switches is always the same on OPP. So like it just reads all the switches at once. So it doesn't matter how often they change. The bus traffic will basically the same. So that won't do anything. And pulsing coils, yeah, we can totally do that. That's simple. But even now, I'm like I can do like a lot of times, and it still works perfectly. Let me show. So that's still, I mean, that's still just working. It simply doesn't care. And if you're about like if you're about to reach the limits, you will see that in the MPF log, because you will start to see like CRC errors or transmission errors, and you can actually reach that, but not with switches. More like yeah, even with the switch matrix, that doesn't matter. That's still always the same. So it doesn't matter if they change or not. I mean, it will transmit a little bit more, a few bytes more, but still it will always read all the switches. So it's also not much, right? One switch is 1 bit, and it's then packed into like a large message. So that's not very expensive. And I mean, yeah, if you pulse a lot of coils, as I just did, that also doesn't do anything. You have to be a little bit careful with a lot of lights. So especially on the older CPUs, which I got, and if you got chains, so like if you run like chain to 20 boards, or I mean even like 3 or 4 boards, and you got a lot of lights, it's possible to saturate the bus there because it's not very fast. You can totally do that. That became harder on the newer CPU because every CPU has its own USB connection. So you could maybe saturate one, but we implemented stuff like hardware fades, so that MPF just say, yeah, fade this LED to this color within 200 milliseconds. And that will be just one command and not like one update every millisecond, because that would be probably too much. And in MPF, we try really hard to prevent you to break it. I mean, with I could see errors. Yeah, that's totally true. So that's why I think the default is 100 Hertz at the moment. And if you got a lot of lights, reduce it to 50. That still works fine. But with the STM32, I'm not aware that you can break it at least not easily. I mean, if you really do light shows without fading and a lot of changes, you might be able to do that. But then keep in mind that, for example, Stern Spike also just runs a bus which is 4 times as fast as the OPP bus and has much larger or basically much longer messages. And they run like 4 or 5 boards. So effectively, they got less bandwidth per board, and with larger messages, it's definitely less LEDs which they can update. And even Stern machines. I mean, if you actually snip the bus on a Stern machine, you sometimes see CIC errors because they overload the bus. But as the software handles it, you do not notice as a player. I mean, it's rare, but I've seen it. And the same is on OPP. You can overload it, but not in a way that it actually breaks. Yeah, Chris. I mean, if you want a cheap solution, this is your hardware, really. Because for a normal machine, it's like $60 or something. And then, I mean, get an old machine where the playfield still has all the mechanics, and you got like transformer, and then you're already ready to go. So what am I using? So I'm using basically all of it. I got like fast hardware in my one machine, and in the other machine we got PROC hardware, so the P3 rock. But yeah, I also got this OPP board. I had spike boards on the same setup, basically also on a plywood for some time, just to install it. And I also had like any other. Yeah, I got the I got the Pinot Tower board. That's the board from Ben Heck, right? And that's also really cool hardware. And they made it with MPF support out of the box, basically. Virtual hardware, yeah. I mean, you can use simulation, or you can run the MPF monitor. That's totally possible to develop your game with the MPF monitor. I mean, you cannot develop physics in the monitor, but you can do everything else. Yeah, right. I got the OPP on my desk at the moment, so that's also great. And soon, hopefully soon, when the electronics crisis is over, I will get my Cobra board. So as I'm the primary person adding like hardware support in MPF for hardware boards, I got almost all of the boards we support. So I do not have a P-Rock, only the P3 rock, but it's very similar. So that's why I do not have it. Maybe I will get one soon for another project. Yeah, now you see it, for example. Yeah, this happens if OPP has like transmission problems. That's what you get in your log. No idea why this just happened, but I'm also polling this at a very high frequency, so it might have just lost one message for some reason, and this is what happens then. Then you know that something is wrong with your bus. Let's see, I mean, it still works. So it handles it gracefully, but apparently something got stuck here. But this CPU on my PC is also quite busy because it has to transcode all the stuff here, right? And run 2 cameras. So it's not that idle. And MPF is also not running with real-time priority and so on. So there are certain things you can do to make this even a little bit more a little bit more reliable. But yeah, I mean, it happened again. So I don't know why, but I don't know that. I know earlier we had crashes when this happened, but that also no longer happens because quite a few people are using it, so it became quite stable. So yeah, I would really like to do this flipper exercise. So just program a rule and trigger it via this input, but I don't know why it doesn't work. But I will look into that later because I actually want this to happen just to measure it. So maybe something is wrong with my setup. Now that's working. Maybe I'm programming it wrong because it's on the second wing. I don't know. But still, let's just use the default 100 Hz. Yeah. So what you have to keep in mind with this like poll frequency is like if you set it too low, then at some point it will you will miss switch changes, right? So at 100 Hertz, the switch has to be active at like 10 milliseconds. Or otherwise you might lose it because it's between the two switch reads. And that's something you do not want. So 100 Hertz is generally fine because even a very fast ball going through an opto still is active for like 10, 15, 20 milliseconds. So you will see that. Like 50 Hertz is probably the edge where it gets, where it starts breaking, right? Where you might lose stuff. But no, that should go away. But still, that's still super, super fast and fast enough. Yeah, in general, it's really stable hardware. You have to take care about the inputs really. So never ever connect your input if you connect your input to any voltage, right? So if you connect the input to 12 volts, you will fry the CPU, which isn't very expensive because it's $4 only. But unsoldering your wings and soldering to a new CPU, that's a lot of work, and it's not nice to do. So just be careful with the inputs here. So that's really easy to fry the board this way. Also depends on if the firmware implements store changes. Yes, but I think we can look at it. Let's just look at it. Like a poll task in MPF, which does the polling. Let's see. And yeah, it just sends the poll and then we get the message back and we can look at it just to see. Update the stage with inputs that are active. And now it looks like we are just reading all the inputs and comparing them to the current state. So yeah, you could do that, but and I know that a lot of hardware platforms actually send the changes. That obviously has a disadvantage. If you lose a message, you have to resynchronize somehow. That's easier here, but yeah, those wouldn't lose it. And for example, in like in Spike, for example, you get a message that that there was a switch change on a certain board, and then Spike reads all the switches like OPP does. And sometimes you get this message, and afterwards, nothing changed on the red switches, right? And then you know that something happened, but you don't know on which switch. yeah, thanks for joining on, Cobra. Hope we will see soon, and I'm looking forward to your hardware. Really, that will be awesome. And do you have an out-of-the-box test script that you can run to see if your board is running? I mean, out-of-the-box test script, no, I got MPF hardware scan. That's always hardware scan. That's always a good idea. Just run this, and if this is showing you the inputs, then you're fine. In general. What I want to do is that's why I tried this setup here. And that is something which would be cool, like to prepare a generic cable where you connect the outputs to the inputs, which are just next to each other here. And then we could do a generic test script to see if we could read inputs, right? Because we know this coil should enable this input. And then we could also do the rule thing I talked about earlier. And we could do a hardware test command where it asks you, yeah, did you put this special cable on it? And if you confirm this twice and swore that you really did it, then we would test your hardware and see that those inputs and outputs actually work, so that the coils work, that the inputs work. And we could also measure your setup and tell you, well, yeah, your input latency is like this, and your coil rules got a latency and jitter of this. And that would be something which I want to have now. And this is basically my test to see if we can measure it. And now I only have to program it. But that can't be hard. So yeah, maybe next time if I show the Cobra with boards, then I might have that. Yeah. So basically that's about the OPP boards. I mean, you feel free to ask more questions if you got any, but that's generally what I wanted to show to you. I hope you got an impression about the hardware and the video format in general. On Saturday, I will show you serial LEDs, and I was at Philip where we built our pinball stuff, and I was a little bit, I was surprised how much serial LED stuff we actually got. I can give you a sneak peek in a second. So we got all kinds of stuff, like the Fate Candy. We got this is the wrong box. We got some. We got some custom inserts we fabbed in China. We got standard off-the-shelf stuff from, for example, there's other fast LEDs. We got yeah, it's a PCB unpopulated from China. We got those small stripes from Adafruit, which are 8 LEDs. We got some lenses, large lenses, for example. We got small lenses. We got, typically those are small lenses, also for a few cents from China. We got chips where you could put your own LEDs on serial buses, but those rings, this actually RGB W LEDs. So they got a white channel also. This is the PD LED from Multimorphic, the board here, which can also do serial LEDs. There's those stripes, and that's probably not even all I got. So I will show that on Saturday, and there will be hopefully a lot of lights, and we will see how serial LEDs work and what form factors are there, and maybe also how to build your own light boards if you want. I got some examples because I fabbed I think 3 different ones in China, and that's what I will show. Initially I wanted also to show parallel LEDs, but as I found so many serial LEDs, I think that will be enough for now. And that's actually it for today. Solid state pinball in Kansas City. Will it be happening this year or will it be next year? I mean, I heard that some pinball conventions actually already happen, right? It's okay. It's a shop. So like it's like a bar or what is it? But if I mean, I'm located in Germany, so if I'm to the US, then maybe I have to. Nice. Only pinball. That's the best places. Only the right people. Yeah. Thanks for joining in, guys. Taking the time to listen to me. Yeah. Saturday will be a lot of lights, and I hope to see a lot of you soon on Saturday. So have a great remaining week. Play some pinball, gather awesome people around you, and yeah, just keep hacking and have a great time. Oh, Philip, hi. Thanks that you joined in too. Philip is the guy I'm usually building pinball with. Yeah, it's awesome that you all joined. So yeah, maybe we will do some. So we always hack pinball on Tuesday. So maybe we will also stream from Philip's place where we got our machine. But it's still there's still a lot of stuff in boxes, so we will have to hack a few things, but then we can show the machine, and Philip has a lot of tools and a lot of stuff at his place, and that might be awesome too. So Quinn, also thanks for joining. So, and Pooty, and hopefully I didn't miss anybody. Thanks for joining, and have a great evening, everybody. Yeah, I should have a pinball in the background, right? But that maybe a no, a virtual pinball is fake, but I should do that. Yeah. Thanks everybody, and good night. See you next time.